Hello everyone, welcome to DC Minds. In this video, we are going to learn about basic of linked list and let's see a real life example from which we can understand the linked list. Okay, so we all of us have seen a train, and if we see this train, what is there in this train is one there is one engine, and this engine is connected to one coach, and again this coach is connected to another coach. So if you observe this, there are multiple coach and in which one coach is connected to another coach. So similarly in programming language, we'll have lot of data, and each of these data will be connected to another, similar to here how one coach is connected to another coach. So when we represent this data using linked list, it will look like this, where each data will be represented using a box, and this box will have two part. One will be having some value, another will be connected to this uh, another box. So each data is represented using a box, and one box is connected to another box. So if you see at the end, it will be pointing to null. Null means nothing. Nothing means here it is not connected to any other data. So similarly, how this last coach is not connected to any other coach, here also we have only four data, and last data is not connected to any other data. So this side of the link is called front side, means basically this is called front side, and this is called rear, means rear side. Okay, so this one box in programming is called as node, and it has two part. The first part is called data part, where we'll store the data, actually value, whatever value we have, and next part is called links. This link is nothing but it will contain the address, that is nothing but the address of next node. So it will connect contain the address path that will point to next node. Okay, so if you define a linked list, it is nothing but a linear collection of data element. Linear means one data is arranged in sequential manner. Data are arranged in sequential manner, but its memory will be random in program memory. So it will be allocated, each box will be allocated memory in different location of the program memory. Okay, so let's see what are various operations that we can perform on a linked list. So suppose initially we have a linked list like this, and we have this side front, and this is called rear side. So now we want to add one data from the front side, means from the beginning of this linked list. So what we can do, we can create a box for this, and we can attach to this 5. So it will look like this. So we have another box, and this box is pointing to this 5. So at the beginning we are adding the data. So this is called insertion at the front. So similar to that, we can add the data at the end. So in this case also, what we can do, we can create a box and attach at the end. So it will look like this. So in this case, this 2 will be pointing to at the this newly created node, and it will be pointing to null because it is not connected to any other node. So this is called insertion at rear. So now similar to insertion, we can perform deletion operation, means we can remove data from front side or data from rear side. So suppose if you want to remove the data, this data means from front side, so the linked list will become like this. So what will we have deleted the data from the front side, so it will have only one data left, and this will look like this. So this is called deletion at front, means from the beginning of the linked list we are deleting the data. Similar to that, we can delete from the rear side. So the linked list will become like this because we are deleting from the rear side, and at the rear this is the last element we have. So we have deleted this, then the linked list will become like this, and this is called deletion at rear. So these are the four basic operations that we perform on linked list. There are some more operations that we will be seeing in upcoming videos along with their implementation details. This is just an introduction video. Now let's see this each box is called as node. So how can we write a code for a box in this video? So now this is a box, and this box look like there is a two part, one is data, another is link. So and this box is called node. So in programming we have to write code like this. First we have to define a structure, and if you don't know the concept of structure and pointer, you can watch my video on structure and pointer. I have made that video especially for understanding the various data structure like linked list, graph, tree. Okay, I'll be giving the link of that video in the description below. So here what we are doing is we need to write a code for node. So in this case we have to create a structure and name whatever the name you want to give. You give the name and this structure. And in this case we want two things. One we want is data, another we want link. So this data is this I am taking of type integer, means I want to store integer data, and I am taking the link as struct of type node, means same type that we are defining. This is because this link will be pointing to another node, node which will be of same type. That's why this link is of type struct node, same type, because it will be connecting to another node which type will be same as this node. Okay, so this is just a type definition. Next we have to create a box. So to create the box we'll write code like this. We'll say struct node, however we are saying in data, here we'll say struct node and pointer node, and then we'll say node equal to struct node malloc and size of a struct node. So in this case what will happen, this is a malloc function that will allocate or create a memory for this node. So what it will do, it will first I calculate the size of this node, basically size of this data type structure, and then it will create the memory using this malloc, and then we will typecast it using this struct node, because in this case node is a of type this struct node pointer. So that's why we are typecasting, because malloc will return a void type. Okay, so when we perform this operation it will give us a node like this, which will have two parts. One will have data, another will have link. Now we can add value to this data part like this. So when you say node arrow operator data, it will what it will do, it will store 5 here, and this link means link equal to null means nothing in the link, because we have just creating a node. So this will finally look like this, where data is containing 5 and node this link is containing null. So this code is written in C programming. So this is in C programming. We will do this node creation like this. But if you want to do same thing in C++, we'll write code like this. Here we'll just say node star node means node pointer, and then node equal to new node. We'll use new operator to create a node, and then similar operation will be happening. Just here these two lines of code is different in C++. Okay, so this is all about linked list. Here just we discuss introduction and what are the various operations that we can perform and how we can write the code for linked list. In next video we'll learn to write a code that will help us to insert data at the front of a linked list. So we'll have data like this, and the beginning will have nothing, means this linked list will be empty, and then when we add all this data, the linked list will become like this, because we are inserting at the front. So first we'll add this 5, so this 5 will be there, then we'll insert 2 in the front of this, and then 15 in front of 2 like this. So front insertion. So this uh, we'll be seeing in next video with coding implementation. Thanks for watching. If you like this video, please subscribe to my channel and hit the like button. If you feel this video will be useful to your friends and your colleagues, please share with them.